In example 2, they give you a word problem that you're supposed to use trig to solve. Now this isn't much different than what we've done before in trig and math 10, but we're looking at it in terms of the coordinates of the directions as the coordinates of the graph. And so we're kind of just tying it in with the whole graphing concept. And your book gives you directions in kind of an odd way. They tell you that this is 200 kilometers from the airport, so that means that the direct line between the aircraft and the airport is 200 kilometers, so that's going to be your hypotenuse, is the straight line. But they give you the directions as east 50 degrees north. And what that means is you're starting at the east line and you're going 50 degrees toward the north. So you start at the east line, you go up 50 degrees toward the north, slightly more than 45, and you write your 50 degrees in there. That's what we would consider to be standard position because the E is the x coordinate. So that's good. That's a nice tidy way to get it started. And we know that this is 200 kilometers. So what they want to know, to the nearest kilometer, how far should they travel in each direction, because they have to travel east and then north. Assuming that they have to travel on roads, and let's say we're in an area where all the roads are set on a grid with 90-degree angles, so like, you know, Alberta. So we would go east, and then we would go north. And they want to know how far they have to travel to go around here. So really what they're asking for is how long are x and y. So we've got our hypotenuse, which is our r, and we have our x and our y, or we want our x and our y. So we want to use sine for y and cos for x because y is always the opposite and x is always the adjacent when we're in standard position. Which means that to find y, I'm going to go sine 50 degrees times 200. Use your calculator, make sure you're in degrees. If you're in radians, your number will be too small. So that's a good way to know. I just punched in sine 50 times 200. Don't forget to close your bracket after the 50, and it tells me that that one's 153.2. Let's just go with 153, and we've solved for y. X is cos 50 times 200, and you've got these formulas written down because we went over those earlier. You don't have to actually figure them out each time. So if I use cos 50 and multiply by 200, again closing the bracket after the 50, then I get 128.6, I guess. So we could round that up to 129. How far did they have to go? Well, they had to go both ways, so 282 kilometers. Obviously, you're going to have to go more than 200 kilometers if you're going the roundabout way instead of just the straight way. So it makes sense that 250 or 282 kilometers is how far they have to travel. In this situation, it's more than 200. Makes sense. You're probably right. Hey look, your book says you are.